Your app is not slow because the CPU is weak. It's slow because you don't control concurrency. At scale, concurrency is not about threads. It's about control, prioritization, and safety. Let's talk about concurrency vs parallelism. Concurrency means handling multiple tasks at the same time, not necessarily simultaneously. For example, downloading data, updating the UI, writing to database. Parallelism means running tasks truly at the same time on multiple CPU cores. Modern smartphones from 6 to 8 cores, big little architecture. Architects must design to use them efficiently. Threading models across platforms. In Android, main thread, the UI thread, and worker threads. Coroutines in Kotlin, executors, thread pools, work manager. In iOS, main dispatch queue, grand central dispatch, operation queues, Swift concurrency async await. And in cross-platform, Dart isolates in Flutter, JS event loop in React Native. Coroutines, instead of managing threads manually, we manage structured concurrency. With Kotlin, you can make a view model scope.launch and take a val from user and async get this user and balance async get the balance. The key ideas: it is lightweight, cancellation aware, life cycle aware, structured hierarchy. Architect level thinking. Never launch coroutines randomly. Always ask who owns this scope. What happens if user leaves the screen? What if task fails? Is it cancelable? Uncontrolled coroutines means memory leaks plus crashes. Background services at scale. App must perform tasks when, in a background, device rebooted, network becomes available, periodic sync needed. In Android, work manager guaranteed execution and foreground service long-running tasks. In iOS, background tasks framework, push triggered, refresh. Architect concern about battery optimization, operating system restrictions, task expiration handling. Thread pool and task scheduling. Creating threads manually is expensive. Instead, use a fixed thread pool, cached thread pool, I/O input-output dispatcher, CPU dispatcher, and in Kotlin dispatcher.io for network and database, and dispatcher.default for CPU heavy tasks, and .main for UI user interface. Why thread pools matter? Without control, too many threads will cause context switching overhead. Too few threads will be a bottleneck. Blocking I/O on main thread will cause Android not responding. At scale, wrong threading strategy kills the performance. Task prioritization. Not all tasks are equal. High priority UI rendering, payment confirmation, security validation, and low priority analytics upload, log cleanup, cache refresh. Advanced system will use priority queues, custom dispatchers, job schedulers. Architect define rules like payment tasks must preempt analytic tasks. Avoiding common concurrency problem. The race conditions means two threads modify the same data simultaneously, and deadlocks. Thread A wait for B and thread B wait for A. Starvation. Low priority tasks never execute, and memory leaks. Uncancelled jobs tied to destroyed lifecycle. Let's take a fintech example. When a user tap a pay button, system must validate the input, encrypt data, send network request, update UI immediately, and log analytics, store transaction locally, retry if network fails, all happening concurrently. Architect ensures no UI blocking, correct sequencing, cancellation if user leaves, retry strategy, thread safe operations. That's real concurrency at scale. Performance optimization techniques. Batch network requests and use structured concurrency. Avoid blocking calls. Use immutable state. Reduce shared immutable data. Apply back pressure. Reactive streams plus coroutines means powerful combination. Senior engineer mindset. When designing concurrency, ask is this CPU bound or IO bound? Can this run in parallel? What's the failure strategy? Who cancel this task? Is the data thread safe? Concurrency is not about speed, it's about control and correctness under load. At small scale, threading is optional, but at large scale, concurrency design determines performance, stability, battery consumption, and user experience. Master this and you move from writing code to designing a systems. Thanks for watching and see you next video.